only 95% of them are being identified as infected by the antivirus scan. So out of those 40 computers, 38 computers are the ones that are really flagged as being infected. It also has what? 95% means 5% chance of generating false positives. So out of those 3960 computers that are not really infected, it flags 5% of them as being infected. So the 3960 times 0.05, 198, these are computers that are not infected but are flagged as being infected. Okay? So totally you have what? 38 are really infected, and how many are not infected but are considered to be infected?
198.
198 are not infected but flagged as infected. So the total computers which are identified as infected is 38 plus 198, which is how much? 236, right? And what is the probability that your computer is one among these 236 computers?
5%.
Your computer is what? One among the computers that it shows a flag that's being infected, right? You see what I said? Nevertheless, you are nervous and you run the software. Unfortunately, it says that your computer is infected with this virus. So your computer is one among those 236 computers. What do you want to know? What's the probability that your computer is really infected or not? Because you see, within this 236, 198 are not really infected. Only 38 are being infected, right? So you want to compute the probability that your computer is really infected, right? So if your computer is really infected, it has to be what? One among the 38 computers, right?
Right.
So the probability that your computer is really infected is going to be really infected is, out of the 236 which are flagged as infected, it has to be one among those 38. So 38 over 236. Right? So if you do the math, it will come to 16% or 16.1%. Is that clear? So this is a very practical problem. You run an antivirus scanner and it has certain probability of detection, and the virus itself has a certain probability of infection. So you get a flag that your computer is infected. You don't need to get scared right away, because you get an alarm that your computer is infected, but there is only 16% possibility that your computer is really infected. Clear? So you could get similar problem in a quiz or exam. You don't have any more quiz, right? Alright.
Thank God.
Okay, so we'll do one more problem and then we'll stop. Okay, so now suppose there is a metamorphic virus, XYZ virus, it is 98% useless bytes and 2% useful bytes. Remember I said those jump instructions and all those things are the ones that constitute a majority of the virus code. Okay. So unfortunately, the XYZ virus has infected your login program on your Linux system and increased its size from 32 kilobytes. Anyone taking down this?
Mm-hmm.
So the size of a Linux login program has increased from 32K to 1032K. So which means, what is the size of the virus code? Right away you can say this. 1000 kilobytes, right? There is a login program. This is of size 32K. And the XYZ virus is attached to that login program. So the whole size is now what? 1032K. So the size of this is going to be what? 1000K. Right? And you know that within the 1000K, what is given? 98% is useless bytes. Only 2% of it is useful bytes. So within the 1000K, how many bytes are really going to be the actual virus code? 1000K
1000K.
times 2%, right? So the real useful bytes for the virus code is going to be 1000K times 0.02, which is going to be 20K. So 20K is the actual virus code that's really going to cause the damage. The remaining 1000 minus 980K are useless bytes.
How many lines is 20K of code?
What's that?
How many lines of code is 20K?
20K is what? 20,000 bytes. 1K means 1000 bytes, right? I'm not sure how to translate this to lines of code. It depends on how you write the code. So basically the program size is 20,000 bytes. So it's not very small, it is a reasonably large program. And no, it's a logging program, so it itself is also supposed to be large, big enough. Right? Okay, so I didn't read the rest of the problem yet. Now Bob has a cleanup program, antivirus software called XYZ sweep. It is able to prune away the useless bytes of the XYZ virus so that in any infected file it will consist of 96% useless bytes and 4% useful bytes. So this XYZ sweep is kind of like an antivirus thing, and what it does is it removes or reduces at least the useless bytes. So that basically the purpose of it is if you reduce the useless bytes, the useful bytes start becoming more dominant or visible, right? Then an antivirus scanner can have some byte pattern and see if it matches with the byte pattern. Okay, so that's the purpose of this. So if you remove or reduce the useless bytes, the useful bytes starts appearing more visible for the scanning. So then it can see if anything matches with its signature. Because the useless bytes, the purpose of them is to do what? Is to hinder the detection process. That's why they are spread around and all those things. So the XYZ sweep is trying to reduce the number of useless bytes so that useful bytes become more visible. Okay? So if you apply XYZ sweep, the infected login program, what is its new file size? Of course, it has to be a lower file size, right? Because the useless bytes are being removed by this sweeping program. Right? And what does it do? It removes such that the thing has only 96% useless bytes and 4% useful bytes. Right? So, how will you tackle this? You know that useful bytes constitute, or the actual number of useful bytes is 20K, right? That's what we found. Useful bytes in the virus code are really 20K, right? On the new version, right? The new version is what? A reduced version of the XYZ, right? After you do the sweeping thing, this constitutes how much? 4% of the total virus code, right? On the new version, this 20K constitutes 4% of the total virus code. That's what it's given, right? So now we can find what is the total virus code.
So 20 divided by 4%?
Right. 20K divided by 0.04, that will be what? 500K. So it's no longer 1000K, the new virus code is total virus code is only 500K. You see that? The actual virus code is not removed. The useful bytes remain there, right? So useful bytes will always be there. It's only one. The cleanup program can prune away only the useless bytes. So it can take away only the useless bytes. So the 20K of useful bytes remain there. Okay, so instead of appearing only as 2% of the overall virus code, once you do the sweeping, the 20K of useful bytes appear as 4% of the total virus code. That's what is given. right? So if it is appearing 4% of the total virus code, then the total virus code, the size of it times 0.04 should be equal to 20K. So the total virus code is then 20 divided by 0.04, that is 500K. So the total thing now is 500K instead of 1000K. So then this becomes 4% of it, and the useless bytes is 96% of it. So now what's the total size of the infected program? 32K plus
500K?
500K, so 532K. So that's the final answer. Okay? So the new size of the infected login program is 32K plus 500K. So you can draw like this and then do the math. It will be more easy to visualize. Okay? So these are the two math problems I could ask in this chapter. Okay? Alright, so we'll stop with this, and there are a few more things to complete.